Hey, welcome back. I'm just doing some quick videos, kind of getting them done as rapidly as I can in the middle of a lot of other things going on. But we're talking on this one about vertical tangents. So remember, a vertical line really has an undefined slope. So I'm looking for where the slope of this particular function, or I guess maybe just equation, has an undefined slope or is vertical. So we've got ourselves a little implicit derivative that's going on. I kind of thought I had my screen up, but I just realized I did not. So let's just open up that to sharing mode. And so let's go take our derivative. So derivative 2x squared, of course, is 4x. Now we've got a 3xy. And so remember, we want to treat this like a product rule. So think about f prime g. So that would be f prime g plus g prime f. Then we come over to here, and remember, implicit derivatives can be a little bit tricky because I need to take the derivative of 1/2 y squared. So you want to really think about this as 1/2 of y squared. So chain rule would say take the derivative of the outside. So 2 times 1/2 would be 1. And that's going to be y to the first power, because remember, we dropped that one level, but then we also multiply chain rule by the derivative of what's inside. And of course, that's dy dx. And then if the derivative of -5 would be 0. So if we were to factor this problem and take a look at all of the pieces that have a dy dx in them, we have the 3x right here, and we also have the y right here. And I'm going to go ahead and move these two pieces to the other side, -4x minus 3y. And last but not least, a little quick division. Now, that would be awesome if the problem was asking me for the derivative. And I have that derivative. I have that implicitly defined derivative where x and y are mixed together. But I didn't ask for that. I wanted to know where it's undefined. In other words, when is 3x plus y 0? Or in other words, I could say equivalently, when is y equal to -3x? Now, on these problems, beware, this will show up on your test. This will show up all over the place. I now need to find out what value makes that true. So I'm going to go back to my original problem, which is 2x squared plus 3xy plus 1/2 y squared is -5. And I'm going to replace each of those y values with a -3x. And so I've got 2x squared minus 9x squared plus 9/2 x squared equals -5. Now, I'm not a huge fan of that way that looks, so I was a little lazy. I was kind of going through my answer key while I was doing senior seminar here, but so I guess I wasn't totally paying attention to everything that was going on in there, but I had to get this thing done for you guys. So when I put this all together, I just doubled everything because I thought that made it look easier. And I got that -5x squared equals -10. And that means that the two places where that would be equal to 0 would be at plus and minus root 2. So it looks like 1 is true, 2 is true, but it looks like 3 is not true. X equals 0 is not a particularly significant value. So we're looking at 1 and 3 only. And I'm looking at this thing and saying it has a vertical tangent. I thought it had that answer on there somewhere. Hey, John.
Hey, we're supposed to be here.
Oh, sorry, it was 1 and 2. Yeah, we're supposed to be here. So answer D it is. We got it. Okay. So maybe I have enough time to do maybe one more of these, and then I will see you guys back soon. So keep in mind, they're telling me that f and g are inverses of each other. So according to this, if I'm looking at g, I'm saying that if I plug in 2, I get 1. But if f and g are inverses, that means if I plug in 1, I get 2. That's the opposite value. And since that's the truth, I know that g prime of 2 is 1 over f prime of 1. So remember, you don't have to work super hard to get the inverse. We don't even need to find the inverse. We just need to go ahead and know the original function. So let's find f prime, which would be 3x squared plus 1. And if I wanted to find f prime of 1, I'd get 3 times 1 squared would be 3, plus 1 is 4. So 1/4 it is. You can hear my next meeting is about to start, so I better get going. But that was problems 3 and 4. I'll see you back in class. Bye-bye.